Well, good evening, everybody. Welcome to Ellensburg, Washington, USA. The local time here is 5:48 p.m. We will begin our program tonight at 6 p.m., the top of the hour. The topic tonight, Ice Age Erratics. Thank you for joining us. How we doing tonight, everybody? Feeling okay? Sounding okay? Looking okay? Port Townsend, Union Gap. Are we communicating? 5 by 5. Like to see that. Thank you, Mr. Bill McNeil. Picture and sound good. Excellent. It is a sunny evening here in Ellensburg, but we've had sustained winds the entire day. 30 miles an hour, pretty steadily. Looks like it's just starting to die down, but I'm glad that we're indoors tonight. This is our second night in a row of being in the front porch, and things are supposed to calm down tomorrow, and if the paint crew outside quits in time and there's enough room for my chalkboard area to set up, I would like to be outside tomorrow night, but no promises. We'll see. The painters have been working extremely hard. They're still scraping and sanding and caulking, and it's quite loud. Bijou's very nervous during the day, and I get to sit in here and work on my computer all day, so this is always a nice way to break up the day by visiting with you all. Let's look at the schedule. Hope you enjoyed last night. We talked about Glacial Lake, Missoula. And tonight we are back in Washington talking about these Ice Age erratics. There are erratics other places, of course, but we're going to be focused on Washington tonight. And then tomorrow night, if you care to join us, we'll be back in the Pacific Northwest, but we'll be going downstream from Missoula Gap, basically following the Columbia River downstream between Missoula Gap and Portland, Oregon. And I suppose up and down a few times. But the Columbia River Gorge is the title and the topic for tomorrow night. Plenty to talk about. And then Saturday and Sunday, our usual time, which is 9 a.m. Pacific time, talking about Maima Mounds on Saturday, and earthquakes, and more importantly, and more specifically, tsunami, and what evidence we have for tsunami in Puget Sound. And that's a developing story, so I'm hoping to get some late-breaking discoveries and data from folks that I know who are doing that work. Who else we got here tonight? Iowa. Oh, I saw some kids' names. I'm Ryan and Jack. Hello. I saw some other kids' names that flashed by too quickly. Punky, you're on house arrest. I guess we're all on house arrest, so thank you. I'm glad this is giving you something to mentally escape your house arrest. Troutdale, hello, Jeffrey. Nebraska, hello, Patrick. Matt is here, thank God. Nilgiri from Sudbury, I think that's what it says. Thank you. Was it Sudbury? Yes. Ontario. Lebanon, Oregon. David, seems like you're a regular. Jody, hello. Garrett from the Netherlands. Subscribe down below. Hello, Kathy. Stacy's here with Benjamin. Evelyn, I think I saw you fly by. Leslie. Daryl from Australia, I think you were here last night. Robert needs a haircut. So do I. Don't we all? You know, Heather says, Ice Age Erratic's my fave. I got some things to say, but I guess I'll wait till 6 o'clock. Well, I'm glad you're excited for it, Heather. I think it's a cool topic, but yeah. Oh. Bruce Bjornstad in the building. Is that a first? If it's a first, nice to see you here live, Bruce. Okay, I got to thank you tonight. This arrived in the mail today. A nice note inside from a family in Woodinville, Washington. I'll read you a portion of the note. And it says, Nick, I see you're getting lots of wine, and I thought you'd enjoy some of our homemade wine corks. So here's one of the homemade wine corks. And here's another one of the homemade wine corks. They're made from driftwood we find on our beach on Whidbey Island by Coopville. I normally give them to friends and family, which you feel like to us. Enjoy, Bob and Kathy. So Bob and Kathy, thank you for the gift. We're corking, we're drinking, and what are we drinking this evening? We're drinking Cheryl's gift from a winery in Walla Walla, I think. Disastrous by Nature. And I didn't read the tag or the label last night carefully, but I'll do that right now. Volcanoes erupting, a rogue 300-foot wave, mammoths roaming wild, humans fishing and foraging. This was the landscape of the Columbia Valley more than 16,000 years ago. A series of catastrophic events brought basalt, sand, silt, and granite to the soils of this region, priming it to grow the deliciously complex grapes that went into this wine thousands of years later. So I don't know who operates this winery and this particular wine and this label, but I'm getting a kick out of it, and I'm definitely getting a kick out of it. So, thank you, Bob and Kathy. And Cheryl from last night. I better hold off on that. It's tasting too good. I'm already starting to feel it. Maybe my reading skills are a little better tonight. My mouth was not working last night at all. All right, we got 3 minutes. You got anything else you want to say? I'm going to check one more time. We're doing okay. I noticed there was a little bit of buffering on the replay last night. We do have wind. It's picked up again, I see. No pattern to the buffering. As far as I know, it's just neighbors doing stuff, or I have no idea. And yeah, I'm sure you do, but at this point, it feels like it's out of our control. And I don't know, I might see how much my papers fly around, but I think I want to open the door here. That was kind of a fun chasing exercise last night. I need to get some cardio in anyway. Just in time for Muffler Boy. There we go. Big old Ford 4x4. See, that's how an old person drives. That's my style. Those old people got to represent, you know what I'm saying? Oh, we got Ryan Carlson here too. Is that true? Ryan, are you here? I might come to you and Bruce a little bit. If you guys just want to lay in the weeds, that's fine. But we might, at some point, I might ask you to share a few specifics. Hello, Rob from New Zealand. I know you've been with us before. Good, Ryan. Okay, yeah. So between Ryan and Bruce, we have some experts on erratics with us. And I'm particularly loose tonight. Not the wine now. I'm particularly loose on our plans, so. That was a bad idea. Okay, I got a minute. You give me a second to collect my thoughts and then we'll begin. Thank you for joining us tonight. Well, a pleasant good evening to you all. Welcome to Ellensburg, Washington, USA. My name's Nick. I teach at the college here in town, and we've been doing these geology live streams for many, many nights. And we continue tonight with a topic in the Ice Age, specifically in Washington, things called erratics. And I hope that you enjoy what I have for you tonight. We need to define what an erratic is. We need to try to talk about why they're important to us, how they help us understand about where the ice was and where the Ice Age floodwater was at different times in the last 20,000 years. And we can also talk about a brand new technique that's been used more recently, I'd say the last 10 years, and work with those boulders, work with those erratics has given us from brand new precise dates that we're using now to work out a chronology about where water was moving at different times. But I'd like to start with a couple of general comments. You know, I've been talking about Tom Foster a lot lately. He passed away this spring, and we continue to miss him. And I've been sharing with you some programs that Tom and I made over the last 10 years or so. It started with a 2-minute geology series, and then it kind of spalled on to other things. And I think Tom and I maybe made 15 of those 2-minute geology things. And of course, I couldn't keep my mouth shut, so we rarely stayed within 2 minutes. I mean, they went to 4 or 5 minutes, and it was still called 2-minute geology and whatever. But I mention this because our least watched 2-minute geology episode is the one called Ice Rafted Erratics. And to me, the erratics are the most powerful story. I mean, yes, we can go to Dry Falls, yes, we can go to some other places, but if you go to one of these erratics, and if you're a rookie, an erratic is a boulder. It's a boulder, a white boulder, that's out in an area where there's nothing but brown lava for hundreds of miles. And here's this white boulder that's the size of your van or your house. And I think it doesn't quite resonate with people. I think the title of that 2-minute geology episode was Ice Rafted Erratic. So maybe that was just like too puzzling to even click on the thing and watch it. Like ice, okay, I know what that is. Rafted, what? Erratics, don't know what that is. It sounds bad, actually, erratic, like erratic behavior. I'm not going to watch that. But it always puzzled me, why weren't people watching that show? And we'll watch it tonight. It's a little bit more than 2 minutes. And we'll go in the Cozy Fort for a couple of other things as well. But I rarely say this, but I think the erratic thing is you had to be there. To really get the power of one of these big erratics in their native element is to drive out in the middle of nowhere, lava rock, lava rock, lava rock, lava rock, whatever, I'm bored, I'm basically ready to fall asleep. And then here's this huge white boulder out in the middle of somebody's field. And you're like, how did that thing get here? Oh, and then somebody says, well, yeah, that's an erratic. That's from the Ice Age. And then you're like, oh, I didn't know. Was there a glacier here? A glacier came from somewhere and like brought this rock and dropped it, and then the ice melted away? Well, that is one option for us tonight. You do have things called glacial erratics, and we'll talk about a few in just a second. But there's another option where you're like, oh my God, that white boulder, it's out in the middle of this field. I guess the Missoula Floods like rolled this thing like ass over tea kettle, just rolled it from Montana, like in the water, like on the bottom of the flood path. And that's true for some of the erratics. But that there's also some of these white boulders. Do you want me to do it again? Oh my God, it's a white boulder. And somebody says, oh yeah, that thing came on the Ice Age floods. And then you go, oh, tumbled, ass over tea. And they say, no. That erratic, that boulder actually was sitting on an iceberg, and the iceberg was floating in the Ice Age floodwater. And you're like, well, I don't know how you could ever possibly prove that. That sounds crazy. I'm not going to believe that. I don't know, maybe that's why people don't like the program. They're like, I don't believe it. I got one more comment and then I promise I start. I don't really watch the thumbs up and thumbs down that often, but occasionally I'll just kind of see how many comments there are beneath a video or something. With all the stuff that I have on YouTube, if I'm talking about the Ice Age floods, earthquakes, it's okay. Volcanoes, it's okay. Other things, it's okay. Mountain building and trench meanders, it's okay. But if I'm talking about the floods, there's quite a few extra thumbs down. Because I'm talking about floods that are older than 6,000 years old. So, it's a lightning rod issue for some, and we don't need to talk any more about that. But I find that interesting. Okay. I do want context for this. I want context, but I want to show you some erratics right off the bat. Let's just say you've never seen one of these things. You're tuned in out of loyalty to what we've been doing, or you just stumbled into it by accident. Let me show you some of these erratics. Let's start with my favorite photo of an erratic, taken by Tom Foster, Wallula Gap on a spring day. Okay? So we're in the Columbia River Gorge. We're just approaching the Columbia River Gorge from the east. And everything's green. Beneath the green, it's nothing but brown lava rock. That's the German chocolate cake. And here's this white boulder sitting there. And I don't know how anybody could just walk by that boulder if they're up there hiking or looking for petrified wood or whatever. How could you walk by that boulder and just ignore it? And just go, yeah, whatever. Wouldn't you be curious about that? That's an erratic. Here's Tom Foster himself, out by himself, doing a little self-timed thing on his camera. He's near Vantage, Washington. We'll talk about it tonight. And here's a different granite. I'm using granite loosely. Sometimes they're granodiorite, sometimes they're diorites. Who cares? Here's another favorite that when I show this in a live audience, there's always kind of a reaction from the crowd. It's another Tom photo. This one is metamorphic rock. It's in the middle of a vineyard. And you're like, where's that? I got to go find that. Well, you can see this from the freeway. If you drive by Tri-Cities, I forget which exit it is. Maybe somebody can type it in. And if you look just to the west of the freeway bypass going around the Tri-Cities, it's near one of those exits. Look out into the grapes and you'll see it. It's maybe 100 yards off the freeway. You may have like, I never noticed that before. You'll see it when you look for it. Let me give you some more. Now here's some more that are going to look different. I just showed you a bunch of white erratics. Erratics are boulders that do not match the local bedrock. Erratics are boulders that were clearly brought from a long way away because the local bedrock has nothing to do with that erratic. So those were granite erratics with basalt bedrock. Here's basalt erratics with basalt bedrock. And you're like, I don't even know why that's called an erratic then. So this is a very famous boulder in north central Washington. It's called Jaeger Rock. It's near the little town of Mansfield, Washington. So this is a slightly different story. And when you go up on the Waterville Plateau, have you heard of that? It's a very unique area of Washington, the Waterville Plateau. It's a plateau. It's remarkably flat. There's nothing but dry land wheat up there. Major crops of wheat without irrigation water. But it's not just wheat that's up there. Have you been up there? You need to go up there. I don't know, is it legal to go up there right now? Is it legal to go take a drive up to Mansfield, Washington tomorrow afternoon? You should do it if you can. I don't know, am I going to get in trouble now? I've lost track on what phase, we're still phase 1, whatever that means. Anyway, you're essential, maybe, I don't know. Go up and look at all these wonderful erratics. So I think the question I want to start with is, are these erratics that are up on the Waterville Plateau, are they from the Ice Age floods? Like those granites were? How can you tell if an erratic was moved by ice, or moved by water, or moved by water carrying an iceberg where the boulder is riding on the iceberg? Like, how can you figure that out? That's the first half of what I want to do with you tonight. It involves a little bit of logic. And then we'll go to the new technique we have for the boulders, and then we'll go to you with some live question and answer. I don't know, I had a thought about a little prop. Half the time I do these props and it's like, it's kind of pointless. I already just said it. But people seem to like the props, especially since I never try them out ahead of time. So let's do it. Why not? So I got a bunch of tumbled rocks here in this mug. All right, kids come and visit the department and they ask some questions and get their merit badge or whatever. Then I go and they can go into the secret drawer and they can pick out their favorite tumbled rock. Okay? So these were donated to the department by somebody died and they had a whole basement full of these and they didn't know what to do with them. And I said, I'll take them. So the visual we want, remember this? Our map of the Pacific Northwest showing how much of the Pacific Northwest has brown bedrock. The German chocolate cake, friends. And so instead of dumping a bunch of kitchen flour on this is the same map I did that and I cleaned that up. And I don't dare use kitchen flour in the front porch here. But that's okay. We're not talking about the pollutes tonight. We're talking about erratics. So we need to get a bunch of boulders onto the top of the German chocolate cake that clearly were coming from areas outside of the German chocolate cake. Oh God. This isn't flour. This is going to be a bad idea. Okay, I'm going to sag. Okay? We got big effing boulders on top of this German chocolate cake, and none of them are brown. None of them are actual basalt. But they're sitting there. They're hundreds of miles in some cases away from their source. In fact, Some of these erratics that are sitting on top of the German chocolate cake are from Montana. No kidding. The bedrock of Montana, our topic of last night, kind of, is very unusual. And we can see easily places in south central Washington where we have Montana rock sitting on top. But I got to add one more thing, because I had some pictures of some basalt erratics, didn't I? I did. I don't know, can you see that map from where you are? I think you can. So my favorite food analogy for the erratics up on the Waterville Plateau are milk duds. I had to go to 4 stores this morning to find some milk duds. I don't know what's going on. These are hard times. The Circle K finally had it. Okay? Milk duds. This episode of Nick from Home brought to you by Milk Duds. You gotta love it. Okay, so there's milk duds on top of the German chocolate cake as well. And so from this point forward, I'm going to do some work with the whiteboard right now. From this point forward, these are the milk duds. The erratics are nothing but basalt, and they're found specifically in an area called the Mansfield Plateau, the Waterville Plateau. And then separate from that, we need to talk about these polished rocks that are clearly light colored erratics. And there's a different story to tell there. We good? Okay. How can we tell the difference? What are our 3 choices? Ice sheet brought them. I have 4 choices. Ice sheet brought them, Alpine glacier brought them, Ice Age floods tumbled them in, ice rafted erratics floated in on icebergs on the top of the water. All right. The best way to handle this is to look for context. Like, it's common for me to get an email and they say, hello, can you please help me identify this rock? And they just have a picture of their rock like this attached to the email, and I have no context. I don't know where they collected the rock. I don't know anything about the context of where and why they found that rock. And that's crucial if you want to try to figure out what kind of rock it is. And you're like, really? Can't you just look at this photo of the rock and tell them what it is? Well, as a geologist, you're often using the bedrock around the area to rule out a bunch of, dumb answers. You don't want to give a dumb answer. And so if you're collecting something in the North Cascades, it truly could be any kind of rock. But if you're finding a rock out in Cooley City, Washington, there's only a couple of choices. Okay, so ice. We've done this a number of times. This can be the ice sheet. This can be the ice sheet moving from north to south. This can be the Canada ice sheet moving from north, from Canada, south across the border into Washington. And there are big erratics being carried within the ice, and then those big boulders are going to be dropped at the edge of the ice. And then the ice melts away, and we're left with all sort of scattered boulders on the ground. So, how can we be sure that a boulder was deposited directly by the ice? In the case of the milk duds, in the Waterville Plateau, it's not just the fact that we have all of these erratics being basalt, but if you dig, this is the context part, if you dig into these low areas, and you dig out in front, and you dig behind, and you dig to the east, and you dig to the west, you find glacial till. You find a bunch of this poorly sorted rock that was deposited directly by ice. Also, as far as context is concerned, these erratics on the Waterville Plateau are also in an area where we have eskers, which are these Ice Age rivers that were flowing through tunnels at the bottom of the ice. And cames and other little terms we don't need to get into. The point is, if you're only looking for one main message, do you know these haystack boulders in northern Washington? They have nothing to do with the Ice Age floods. And I think that's a big message, and maybe a surprising message to many. These are big boulders, for sure. They were deposited by ice, for sure, but not deposited by the Ice Age floods. You want to put that into context? These are stale milk duds. They found one box in the back room somewhere. All right, so we are here. Our milk duds, our stale milk duds, are deposited after this ice is melting back, as the ice is advancing forward, and there's even a beautiful glacial moraine called the Withrow Moraine that shows perfectly where the southern edge of this Okanagan ice sheet was 16,000 years ago. Okay? So that's really not where we're going to do most of our work tonight. But these guys, the milk duds, even over by Lake Chelan, the milk duds, basaltic erratics with basalt underneath. So that means, I'll do one more thing with this. So our milk duds are sitting on top of the German chocolate cake right here, which means those milk duds did not travel very far in the ice. Because you can see that, I don't know, what is this, 50 miles maybe? 50 miles to the north of the milk duds, you lose the German chocolate cake bedrock. So here comes the ice, picking up basalt, carrying basalt milk duds, and then dropping them less than 50 miles to the south. So this is kind of a local story, but those haystack rocks are so impressive. They are everywhere, and they're so big that they're actually farming. They're farming around those things. They're like, we're not going to move these things. They're so big, and they've been sitting there since 16,000 years. They haven't budged a millimeter in 16,000 years, and we're going to farm around them. Okay, you got that point. Switching gears. Thank you for your attention. Who knows if you're paying attention? It doesn't matter. But most of you are. Those questions that you always have are so right on the mark that I know most of you are really paying attention. Okay, a more, I think, interesting question and complicated question. How can you decide if a boulder was tumbled by Ice Age floodwater or rafted in on top of the Ice Age floodwater? And I'm getting hot. How's it going? Oh, I'm kind of busy right now. I can't talk.
I know.
Yeah.
Brogan asked me to drop this off.
Oh, Brogan did. Okay. Well, thank you. Appreciate it, man. So Brogan from Seattle, your friend just came and delivered some Chinese food, I think.
Curry.
Curry. Thank you. Some curry. Oh, that's the aardvark guy. Okay. All right. Whoo! So here's a valley. Let's make it easy on ourselves. We got a nice big broad valley. And we're someplace in eastern Washington. We're not worried about slackwater sediments tonight. We're not worried about coulees even tonight. We're just out here in the German chocolate cake, and we've got these boulders that we have to explain. Now, we need context. We can't just zoom in and frame that boulder as tightly as we can. We need to take a survey of the lay of the land and use some logic. We're going to find a bunch of boulders down here. And we're going to find a bunch of boulders on the hillsides over there. This isn't too hard, is it? We have two choices, and we have two mechanisms for bringing these erratics 100 miles and dropping them on top of the German chocolate cake. What are our two choices? Did the flood bring them in there with the water, or did the flood carry them in on blocks of ice? Okay, first thing is just looking at the position of the boulders, and I think I'm mainly talking to kids now. So if we have a big flood, F-L-O-O-D, and that flood is coming right at you, and we've got hundreds of feet of water moving very quickly, and it's coming right at you, which of these boulders, which of these erratics were dropped by the water? Kids? Which of these boulders were dropped by the water? The answer is those. Why? Well, they're at the bottom of the valley. And they're probably rounded. And as you take a big boulder and you bounce it and roll it and send it down the bottom of a channel, you're going to knock off its corners and you're going to make it more and more rounded. Just like a river rock that's a normal river rock. But these are boulders the size of this front porch and bigger. So we can make some evidence, we can collect some evidence and make a call that the more rounded boulders that are in the bottom of a valley, in a place of low elevation, in the middle of a flood path, those are likely going to be flood tumbled boulders. But maybe the surprise to many of you is we also find these erratics hanging out on hillsides, sometimes pretty steep hillsides. So why is this a favorite photo of mine that Tom took? Because we're at the top of Wallula Gap. We're hundreds of feet above the Columbia River. And we're off to the side of the main flood path as this water is cruising through and even over the lip of both sides of Wallula Gap. And what's your thought here? Did the floods roll that one in? I mean, it's a more angular boulder, and it's up here high, hundreds of feet away. So again, kids, I hope that you can see that those erratics were rafted in on icebergs. And you're like, hold on, I'm not a kid, number one. And number two, I don't think I can really believe that. I don't think I can believe that, number one, because you're saying the flood top was here, and you're saying the boulders are below the high water mark. Why would that be? And I don't know, maybe it could be something else. Does it really have to be an iceberg? That seems like such a freak show, like a Yukon Cornelius kind of a thing. That doesn't happen that often, does it? And the answer is, yeah, we think it is quite common. Let me finish this train of thought, and then we'll move on and give you more photos and a more specific example at Vantage, and that's why we need Ryan Carlson with us. So these, if you haven't caught it, I'm not going to write it out, are the erratics that were brought in 100 miles from northern Washington, from northern Idaho, even from Montana, and they were brought in by the Ice Age floods, but they were not tumbled in the water. They surfed in. These are rocks that surfed in on top of the flood. And they were surfing not on surfboards, but they were surfing on these huge ice cubes that we call icebergs. Now, if you remember last night, we had that big ice dam many times, multiple ice dams, right, in northern Idaho. And when we drained Glacial Lake Missoula, we had the water kind of tunneling underneath the ice, and then eventually that ice dam just collapses and breaks into a bunch of pieces, and away we go. Those are the icebergs. That's the most common thing to visualize, that we're floating things in on icebergs. Let me give you some artistic renderings. Now you may have caught it before we started. Bruce Bjornstad, the author of these books, and the author of a couple of illustrations I'm about to share you, is with us live here. And he can kind of stay back in the weeds if he wants, but this is one of my favorite illustrations from Bruce's first book. And he's showing us Lake Lewis in southern Washington. And he's showing us a very specific high water mark of Lake Lewis at its maximum filling. And he's not only showing us that water, but he's showing us these icebergs. And you're like, well, that's cute. He just kind of put that in for artistic effect. Well, no, he didn't. Because of these ice-rafted erratics that we have perched on many sides of the shorelines of Lake Lewis. And if you look carefully, you can actually see this is a real photograph. So there's the freeway skirting around Tri-Cities. And if you know these mountains, Candy Mountain and Badger Mountain, they kept their chins up above the high water mark of Lake Lewis. And you're like, baloney, how do you know that? How does he know that? How does he, the so-called expert, Bruce Bjornstad, wow, how does he know that? Well, it's pretty easy. He's hiked every square foot of these mountains, and below the elevation of 1,250 feet, is that what he says here? Thankfully, yes. If you're below 1,250, there are erratics everywhere. In Tri-Cities, if you're below 1,250 feet elevation, you've got erratics mantling the slopes. But there's not one erratic at 1251, or 1253, or 1260, or 1273. And Bruce isn't the first one to make that deduction. Brett's figured it out. Others figured it out earlier. But Bruce has spent countless hours on Rattlesnake Mountain and many of these landmarks in the Tri-Cities area, taking inventory of how many erratics he's found, etc. Bruce, if you care to chime in with the comments live here, basically in this photo, how many erratics do you think you have found and mapped? And then you can make a separate comment maybe for Rattlesnake Mountain, which I know you've done the biggest inventory, but it's not an exaggeration, is it, Bruce? You have found hundreds, maybe thousands of erratics that are on these slopes after that water backed away. So from carefully looking at all those erratics and knowing the high water mark of Lake Lewis, that gives you the confidence to make a map like this. It's not a guess. This is, again, Bjornstad. He can precisely tell us the biggest size of Lake Lewis by his mapping of these erratics. And most of the erratics showing the high shores of the water are from these icebergs that are working their way to the edge. And I can add one more detail, and then we'll go to Vantage to kind of finish this out. Oh my God. Yeah, okay. Nice job, Brogan. And the show has reached a new low. All right, man. Here's the detail with Lake Lewis. And if you were an iceberg, can you imagine, can you picture a river that's swollen with water? It's a big flood, just a regular river flood. And you got logs coming down that main channel of the river. You've got maximum water coming right down the middle of the river channel. But some of those logs are going to work their way to the edges, aren't they? They're going to get hung up in the quiet water on the sides of the main channel. That is the story that we're talking about here. These icebergs are going to follow the main channel if there's velocity in the channel, but they're going to find their way up into some quiet areas, and many of our ice-rafted erratics are going to do that. I see you, Brogan. I see you. Talk about the power of concentration. Good Lord, it's nothing but you. There's nothing else. The circus doesn't exist behind me. So Bruce has icebergs out in the middle, but we also have many of these icebergs that eventually, can you picture, I'll finish the story in case you don't have it. So what happens to the iceberg? It finds its way to the quiet water, the water drains away, the iceberg is left. It's like a beached whale. This iceberg with this boulder on it, or maybe a bunch of boulders, are sitting now high and dry, and eventually that iceberg melts, and the rock just hangs out there and hasn't moved since the Ice Age. Okay, he goes to the other whiteboard. No, I put it on a piece of paper. So this is my attempt to summarize some of the work of Ryan Carlson, who was a Central Washington University geography student as a graduate student working under Carl Loquist. And his master's was to cover every square inch of the hills above Vantage within Ginkgo State Park. And he's affiliated with the state park, so he wasn't breaking any rules. And he didn't collect rocks, but he inventoried, counted up rocks, carefully marked the location of each of those rocks. And here's the elevation of the town of Vantage. This is 663 feet above sea level. The highest elevation of an erratic that Ryan found above Vantage is this elevation. But I have a question for you, of all ages now, not just kids. He found most of the erratics lower than the high water mark. He found most of the erratics dropped on the hillsides at this elevation. That's more than 100 feet. Yeah, it's more than 100 feet below the top of the bathtub. Why would that be? These are definitely all ice rafted, and the icebergs came in and parked and then dropped their rocks after the icebergs melted away. But why wouldn't all the rocks be up here at the top if the icebergs were floating in on the top? There's a delay in the comments, but I'll wait another 30 seconds. I don't know, can I draw this? Yeah, I saw some of them fly by. Big icebergs. You probably know the rule better than I do, but icebergs float. But isn't it like 10% of the iceberg is visible and 90% of the iceberg is underwater? Like you've got just think of a lake, and you've got the iceberg visible, but there's way more of the iceberg that's below. So if I draw, do you know what I'm going to draw here? So if we generally use that rule that just a smaller portion of the iceberg is above the water and most of the iceberg is below the water, how can we nestle this big iceberg up into this area? Especially if the bigger the boulder, the bigger the iceberg, we can presume. And so we have a concentration of the boulders here, not right here, because we've got a slope to the land surface, and we're basically grounding the iceberg here as opposed to up here, because there's a space problem to fit those big icebergs into that area. Make sense to you? And you might go, well, how are you going to get any ice rafted guys up here? Well, maybe we have a smaller iceberg. And Ryan, if you feel like chiming in, do you remember your grand total? How many actual erratics did you map? And was it just one summer or a multiple series of summers? I saw your master's thesis long ago. I couldn't find it recently. I didn't look hard enough. But great work. And it gives you a little feeling for the depth of the water. So that's what, more than 500 feet of water above Vantage. And this is a flood now. This is not Lake Lewis. Now we're at Vantage. We got water coming right down the heart of the Columbia Valley, moving 40 miles an hour easily, depending on which flood we're talking about. And again, it's this quiet water that's creeping up into the side channels that are giving us a little bit more detail. Okay, I got to move on. I got one more concept I want to try to do in less than 10 minutes if I can possibly do that, and then we'll get to your questions. Oh, and Cozy Fort too. Okay. Wow, I guess Brogan's gone. I hope he comes back. I want to visit with him. But that was bizarre. Before we go to the Cozy Fort, let me give you a crash course in this new technique. I keep saying it's new, but it's been around for a while, more than a decade. But The scientific papers that have come out have been in the last 10 years. And I've been excited to share that information because number one, it gives us some new dates for the Ice Age floods. And number two, those new dates are actually working quite well so far with the old school mapping of Bretz, Vic Baker, Richard Waite, Jim O'Connor, Bruce Bjornstad, and others. So it's a nice situation where the kind of absolute ages and the relative ages in the field, kind of like new school and old school geology, older generation, younger generation, are kind of, that data is intersecting nicely. And I want to make sure you know that chronology before we quit. So I'd like to focus on Andrea Balbus. Andrea's from Oregon State. She got a PhD, and she visited many of the famous erratics in eastern Washington and got some tips from many of those folks I just mentioned. And she had to hunt for just the right erratic. So now we don't care if it's a milk dud that the glacier brought in, or ice rafted, or even flood tumbled. We don't care now. It was brought in by the ice, or brought in by the Ice Age flood water, and can we do something with a new technique to actually put a number on it? Like, when did that flood happen? Or when was that ice here? How many thousands of years ago? Just by looking at slackwater sediments or glacial till, we don't have that precision. So this is the page to kind of describe what Andrea's been doing. And John Stone at the University of Washington, and Joel Gombiner, and a few others. They've been using a process called Cosmogenic radionuclide dating. It's beyond me for the most part. But the concept is you have cosmic rays constantly bombarding the Earth's surface. Some from the sun, some from beyond the sun. But cosmic rays coming in and bombarding rocks and rock surfaces. Now, if you are Andrea, you are on the hunt for the right erratic. So before we started, I'm like, do I actually have an erratic I can use? So I said, well, I found this thing in the basement, which is made out of granite, and it will do a nice job for us because there's some quartz. We need a boulder with some quartz that's sitting on the ground. We got to try to find a boulder that there's no signs that it's been moved by a farmer, that it's been tipped over by some natural forces. We need a boulder that's been sitting there for more than 10,000 years. And you're like, I don't know, can you really say that? Yeah, with a bunch of these erratics, you really can. It's pretty young geologically, less than 20,000 years. So anyway, Andrea finds the right boulders above Wenatchee, up on the Waterville Plateau, Sentinel Gap, Tri-Cities, etc. Now, this is not just a boulder, but it was a gift to me from somebody 10 years ago, and I'm like, thank you. And I tried using it a couple times with a big bottle of beer, and it like spilled all over the place, so I'm not using it right. So this is a good chance for you to tell me, how does this work? Have you seen one of these things? How can I do this without having the whole thing spill all over the counter? But anyway, it's a super heavy present and kind of fun. So it's our boulder tonight, okay? So we have cosmic rays that are bombarding the surface of this boulder. And Andrea, or whoever's doing the work, is going to come in and make sure there's a nice clean surface to this boulder. We don't need any lichen, we don't need moss, we don't need caliche coating, nothing. We need a nice clean surface that's been bombarded by cosmic rays. And then she actually takes a hammer and a sledge and a chisel, and she chisels off a portion of this surface. She goes down maybe 6 inches, maybe even a foot. And she gets a pretty decent sized portion of this surface of this Ice Age flood erratic, or this Ice Age glacier erratic. She sends it to the lab. They look carefully at the quartz grains, and inside of the mineral quartz is silicon and oxygen. That's all that's in a quartz. It's SiO2. And we know that oxygen-16 radioactively decays to a mineral called beryllium, and an isotope of beryllium called beryllium-10. And this isotope of silicon, silicon-28, radioactive decays naturally into aluminum 26. And if you're like, this is over my head, you might go back to our live stream in the backyard. What was it, 2 weekends ago or just last weekend? I can't forget. 2 weekends ago when we talked about absolute age dating. It was a Sunday morning, I remember that. And that will give you a little bit of background on how this process works. But we know the decay rate, and so you measure the daughters, you measure the parents in that quartz grain, and you can come up, you can calculate how many years that boulder has been sitting there since the Ice Age effects or the Ice Age activity, whether it's water or ice, brought that boulder to a particular location. And you might go, well, I just don't see how that could possibly work. This is from Andrea's paper. There's a whole story I guess I don't have time for, but Andrea joined one of our field trips with all of our regular folks, mostly old folks, and she jumped in the back of our van. She drove all the way up from Corvallis, Oregon. She left at like 4 in the morning. She said, I can't believe I got here in time. You guys are going out to Wenatchee to look at some boulders. I need to find some boulders for my PhD. I'm like, okay. Well, 2 years later, she's got this amazing paper that everybody's referring to. I didn't know her at all. That's the only time I'd really met her. So her paper is from 2007, is called 2017. You can read it. I can't read it backwards, but she's talking about beryllium dating from this surface exposure dating business. And this is a terribly complicated diagram, but I want to show it to you anyway. I guess I need to show you everything here. So here are the places in the Pacific Northwest where she found boulders, visited the boulder, broke off the shell, sent it to the lab, measured the stuff in the quartz, and she plotted up those dates. I'm reading backwards, but does this say 20,000 years ago, 17,500, 15,000 years ago, 12,500? And depending on the location, I'm sure you can find this paper online if you're really into this. Depending on the location, she's got different dates, and they, after the results from the lab come back, she's got a bunch of boulders that were dropped 16,000 years ago. She's got a cluster that were dropped 14,000 years ago. She's got a couple of big ones above Wenatchee that are 18,000 years ago. And there's other things she's plotted as well, including evidence of fresh water dumping into the Pacific at the mouth of the Columbia. So that's way too much detail for us right now, but my point is it's more than just like a, wow, look at this boulder, it was brought in by water. We now are gathering some very precise dates. There's some error either way from those dates, but it's helping us figure out where the water was going at certain times. So I feel I have to do this before we go to the cozy fort. I'll just do it verbally. You remember our Glacial Lake Missoula last night. Here's Glacial Lake Columbia, here's Lake Lewis. I'll just do it verbally. From Andrea's dates that add a little bit more precision to what we had before from Richard Waite and Vic Baker and others. 18,000 years ago, there was no Glacial Lake Columbia. The Okanagan lobe was not big yet, and we had some Glacial Lake Missoula water breaking through the ice dam at Lake Pend Oreille and following the Columbia River to Wenatchee and then down to Pasco. Some of Andrea's boulders above Wenatchee I don't have time for it tonight, but this is a map that I made using data from Bill Long, a retired Forest Service geologist, and Stephen Porter, who used to teach glacial geology at the UW. And every gold star is an ice rafted erratic, mostly found by Bill Long back in the 1970s and 1980s. And so these are some of those gold stars are the ice rafted erratics above Wenatchee, Washington, that Andrew was able to visit and get basically 18,000 year dates from. Now you know what I'm saying, right? I'm not saying the rock is 18,000 years old. Right? This rock may be 100 million years old or 150 million years old. Might be a Cretaceous granite. But the dates we're talking about right now is the surface exposure dates to figure out when that boulder was actually brought in. All right, so 18,000 years ago, we have a straight shot where the Missoula water comes down the Columbia and then makes a Lake Lewis. But then, I'll do it verbally, we grow the Okanagan lobe, and by 16,000 years ago, now we have Glacial Lake Missoula water going into Glacial Lake Columbia, and we start doing major floods down the Grand Coulee and over Dry Falls. Andrea has 16,000-year-old dates from the boulder field south of Soap Lake. She's got other key boulders further south that tell us it's a Grand Coulee story. Then Andrea's got 14,000-year-old boulders for when we break up the Okanagan lobe and have one last big ice age flood coming down the Columbia. And so 18,000, 16,000, 14,000 years ago, and not having those floods go at the same place at the same time. Maybe you got that impression last week or so when we were talking about the ice age floods. It's not that we're flooding everything in Washington simultaneously. With these new surface exposure dates and some field evidence, we can have the water come down the Columbia for a time, the water comes down the Grand Coulee for a time, the water goes down Cheney Palouse track for some time. In other words, we can kind of play the movie with a little bit more precision. And speaking of that, that's what we're going to look at with the Cozy Fort. Okay. It's 6:50. I feel I got 10 minutes of Cozy Fort, and then we'll come to you with live Q&A. Appreciate you going. I'm standing now on sticky, stale milk duds with bare feet. That's an experience that I do not recommend. Cozy Fort by Steve. Trademark. It's time to sweat. Got a little sagging in the Cozy Fort lately, but that happens to all of us at some point. So I want to start with a short animation that maybe many of you have seen, and I couldn't find it on my desktop, so I have to go to YouTube. I bookmarked it from one of my downtown lectures. And this is just one flood event, so it's not going to show the chronology I just gave you. But the benefit of this is that we actually have time in hours that's been calculated. So have you seen this before? This is from the USGS. And it's red up there. That red means deep water in Glacial Lake Missoula. And this is the Okanagan lobe that's in place. So this can be basically 16,000 years ago for the chronology that I just gave you. Okay, I have got the sound turned off. Let's just play this thing. Okay, yeah, so there's a man talking, and do you see up in the upper right-hand corner, that's the number of hours since the ice dam broke in Idaho, and the green is Lake Lewis that is building water as the water's trying to thread through Wallula Gap. I just haven't shown you this before, and I wanted to give you a sense of how precise we've gotten with the timing of draining Glacial Lake draining Glacial Lake Missoula and forming Lake Lewis in a couple of days. There's more to that animation, but I don't have it handy. And if you want to find this one, this is, I think, a YouTube lecture called Wenatchee Ice Age Floods. It was okay. It wasn't one of my better ones. What's this? Yeah, this. So I'm going to get pissed right now because I'm going to show you a portion of a lecture that I did at Hal Holmes' lecture downtown. And I'm angry still because they screwed up the microphones. And it's one of my favorite lectures, and the sound is terrible on this thing. But we have to listen to the sound. It's one of my favorite lectures, and the sound is terrible on this thing. All right, hang on. But we have to listen to the sound. Hang on.
There are hundreds and hundreds of these these, and I'm sure that you know where some are located.
I want to show
The
you
granite and fine bedrock matches.
some more exposure dates.
Into bedrock right at Grand Coulee Dam, so that's a possible place for some of the granite erratics. And the locomotion for many of those boulders is to raft on these blocks of ice. Remember, the icebergs are the broken up pieces of the ice dam.
Painting by Stevo Minsky, Teresa Foster.
Really beautiful erratic south of Sentinel Gap, so we're near the town of Mattawa. And John Stone from the University of Washington, using the surface exposure thing I was talking about with the radioactive isotopes, his date for how long that boulder's been sitting there is 14,050 years. Ice rafted erratics near Mattawa, Washington.
We're going to watch that moron.
We got students coming out there, checking out. They love that boulder. You can hike out to it pretty easily. It's about a 20-minute walk from the car. Lake Lewis, we used the mapped locations of those erratics and the rhythmites to put this together, and we can visualize these icebergs floating in on top of Tri-Cities as Lake Lewis is formed. We play the same game up in Wenatchee and up the Wenatchee River. Every gold star here is an ice rafted erratic that came in. The fast moving water was coming down the Columbia and the quiet water was creeping up. This is the 18,000-year-old floods when the Okanagan Lode was not in
Stop.
place yet.
We don't need this love fest. Yeah, here's one more date, and we're going to visit with Andrea just real quick.
Working its way up the Wenatchee River. In fact, all the beautiful orchards that are in the floor of the Wenatchee Valley are on slackwater sediments, to be precise. So here's a boulder that Andrea Balbus dated using the surface exposure 18,200 years ago.
That's
that
Tom.
boulder's been sitting there on Sunny Slope just to the north side of Wenatchee. Andrea, let's meet her. She's at Dry Falls talking to some folks. There's a new technique to work with the surfaces of these boulders to figure out exactly how many years they've been sitting here. In other words, there's a new way to determine the age of the Ice Age floods.
So the cosmogenic nuclide dating technique is very valuable because it brings something new to this story. It lets us date the landforms specifically. So we can go to the Wallula Gap and we can date a giant boulder there and tell you when it was put down and massive water was coming through and backed up behind the Wallula Gap. We can date giant rafted boulders in western Wenatchee and tell you when a massive flood came through that area. We can talk about the Ephrata Fan and talk about when the debris dam failed. We can talk about these events that crafted these geomorphic features through time very specifically for the first time in the study of the Pleistocene megafloods.
I don't know where she is right now. I hope she's got a teaching job somewhere. She's excellent. And I hope she's continuing with that surface exposure dating. We'll finish the Cozy Fort with the 2-minute geology episode on ice rafted erratics. The first one involves amazing erratic that you can all go find if you want. It's south of Sentinel Gap. It's near the little town of Mattawa, and Bjornstad's book pointed me in that direction. It's an amazing boulder, and you'll see it here. It's huge. And then the second half of the 2-minute episode is from an equally amazing erratic that's near Rattlesnake Mountain, and it's erratic made out of Rocky Mountain bedrock that rafted all the way to Pasco, Washington. And yet only 15,000 views. So maybe you get why these erratics are so cool. Not everybody does.
2-minute geology, the 2-minute geology. Hello, young people. Ice rafted erratics near Mattawa, Washington. Erratics, boulders that do not match the local bedrock. The local bedrock here in central Washington is brown, layers of basalt, lava rock, and yet we've got these big light-colored boulders, granites and metamorphic rocks that dot the landscape. How did they get here? Erratics are usually associated with glaciers, ice sheets, bringing these boulders to an area. But here at Mattawa, we are 60 miles south
of where the ice sheet used to be in north central Washington, north of Wenatchee. So this is not from glacial activity. This is from Ice Age floods, ripping off pieces of that ice sheet and carrying these boulders down here. Ice rafted erratics. Let's go a little further south in the Pasco Basin and look for more of these guys, okay?
What a dork. Doesn't the tie piss you off?
How about this beauty? We're on the lower slopes of Rattlesnake Mountain near Benton City, Washington. This is argillite, a metamorphic rock that used to be shale. 1.5 billion years old. This thing's like 12 feet long. It's angular. The Ice Age floods brought this boulder here. This is Rocky Mountain geology brought to south central Washington. Rafts of ice, icebergs, floating in the water, carrying boulders like these. And this guy either fell off of its ice raft, or the iceberg got into some quiet water, stranded, melted, and left the rock. Regardless, this boulder's been sitting here for at least 13,000 years. Ice rafted erratics in south central Washington. It's all out here to see. Coulees, rocks, and canyons is scenery. Right here for you and me. 2-minute geology.
All right. Well, that's the end of my program. I am very much looking forward to trying to answer as many questions as I can. And you know the drill if you've been with us before. We use uppercase. You get on that caps lock and ask a question in uppercase. Kids, grown-ups, doesn't matter. And we'll do this for a little while. And we'll see what kind of questions you might have. It's a pleasure to have you with us tonight. Always enjoy being with you. And again, we've got a couple experts with us that we might lean on if needed. Nick, am I okay? You seem angry. No, I'm sarcastic. And I'm sorry if that doesn't translate some evenings. I am having a great time with you, and I always do. Where is the Afraid of Fan, and how long ago did it first form? Eric, Google Soap Lake and State Route 17. And if you leave Soap Lake on State Route 17, I'm sure you can get down and even on the street view, and it's a 5, 6, 7 mile drive south of Soap Lake on 17, and you'll see thousands of these boulders. And those were boulders that were flushed out of the Grand Coulee and then dropped as that water spread out into the Quincy Basin. And that's mainly a story from roughly 16,000 years ago, and that's where Andrea got a couple of her dates. How many feet above the Columbia River is your favorite erratic? Oh, so that's Jeff from Vinman's Bakery. How many feet? Bruce, if you're handy here, I'm going to guess 800 feet. That white erratic, where'd it go? Unless Bruce chimes in here, I think I'm going to pick the number 800. So we have an 800-foot elevation difference between this boulder and the floor of the Columbia River before we dammed the river. And so we have 800 feet of water easily filling this whole valley and an iceberg getting that boulder positioned there. Now remember, we have dozens of floods, and not every flood has the same volume. There's probably some erratics that are higher elevation than that favorite of mine. But those are the numbers we're talking about pretty regularly. Is there an upper end to how big the erratics are that rafted up on the hillsides? Did some larger erratics sink down and drill holes in the Columbia River basalts? Two questions, John. So the upper, how big do the erratics get that rafted up on the hillsides? There's a few erratics that Ryan found that I've hiked out to above Vantage. I don't know how to approximate them. They're the size of a VW bug. How about that? How about that for a dated reference? And they're, yeah, I can't answer that one better than that. And there are potholes, but I know of no evidence of the erratics drilling the hole. It's just nothing but water. It's just the hydraulics of these underwater tornadoes that do this caulking and just lift this rock up. So I know that if you're a fisherman and you know there's holes that have little kind of grinding stones in the bottom, but I would not put the erratics with the hole drilling. I don't think anybody's discussing that in the literature. Getting hot in here. I don't care if the papers fly around now. Are there any ice rafted erratics downriver of Wallula Gap? Absolutely, Adam. And if you tune in tomorrow night when we're in the Columbia Gorge, I'll be talking about Brett's on foot with his students mapping erratics as he's walking from Portland up to Wallula Gap. So there's high water in the Columbia River Gorge. There's slack water getting up into the side canyons. There's icebergs getting there as well. And definitely a bunch of icebergs all the way south to Eugene from Portland. You may be aware of that if you're an Oregon person. It's a regional story. How can Andrea's dating differentiate cosmic generated decay that occurred prior to being rafted versus after being rafted? That's a great question, Bill. Bill's basically saying, wouldn't you have a boulder that might be exposed to cosmic rays before it gets picked up by the water? I don't know how to answer that question, except to say that I guess there must be some assumptions that those boulders are in the ice or at the bottom of the ice. I guess that's the assumption, that you're not really perching the boulder and allowing it to be exposed until it gets released from an ice prison up in northern Idaho. But I had never really thought about that before. Good question. Is there any evidence of buried icebergs, e.g. kettles? Buried icebergs. Well, there are things called berg mounds where you have a whole cluster of erratics sitting together, a big boulder maybe, and then hundreds of smaller things. And so the idea is that that's an iceberg that had a lot of stuff in it, and the iceberg melted, then all the stuff, whether it's a boulder sitting on top or a bunch of sand and gravel and other things inside, all dropping. But that's not really what you're asking. And I guess you're asking that do we have places where you have kettles now, where we used to have an iceberg that was kind of sitting in glacial till. And because this is such a dramatic flooding story, I don't think we have that. Nilgiri, I'm sorry if I'm pronouncing your name incorrectly. That's more of an ice sheet story where you have icebergs kind of within glacial till. This is so catastrophic, and it's such a broad open bedrock area that the German chocolate cake just doesn't have much material to bury the icebergs. Nick, it is difficult to get good data, or is it difficult to get good data from erratics, e.g. dating, because it may be influenced by uplifts, rebounds, etc., or is it independent of the surroundings? Peter, the surface exposure dating, if we're uplifting the crust because of isostatic rebound, I don't see how that would influence our dates. I don't think anybody's talking about isostatic rebound in the scablands because we never had ice on top of the scablands, which reminds me. I have a daily routine. Every morning I pedal my bike up to school and I just kind of go through my bookcases and bookshelves and file cabinets and just say, what can I use for tonight? And I usually I already kind of have what I need. But I found this morning, and I'd forgotten I had it. It's obviously in tough shape. This is how you spread your scientific papers back in the 1940s and earlier. You made what's called a reprint, and then you personally sent your reprints to other geologists. So this is a reprint from William Hobbs in 1943, and with compliments from the author to George Beck, who was the teacher here at Central Washington University, not called that at the time. And anyway, this is embarrassing for the Hobbs family if anybody happens to be watching, because in 1943, Hobbs proposed that there was a major glacier over all of eastern Washington, and he called it the Scabland Glacier Lobe. And he's talking about Brett's. This is 2 decades after Brett's was here, but he's saying Brett's is wrong, and all these erratics and this other stuff can all be explained by a big ice sheet over Moses Lake, over Connell, etc. Even though Pardee talked him out of it, Brett's talked him out of it, but he insisted. And that's the kind of dogma that Brett's had to fight against. And that reminded me, because there's never ice sitting on top of the scablands, but we think there was some isostatic rebound north up at the Waterville Plateau, but nobody's ever tried to work that out. Figure out how much uplift or how much rebound there's been since the ice left, and how that would factor into things. I would think that you'd be interested in BC geology, but you don't seem to mention it too often. Is the only way Canada's geology affects the U.S. related to the ice sheet? Moto mining, I have major interest in British Columbia. Jerome Lessman is a geologist up there that I met on a field trip 4 years ago, and last year we were all set to spend a week up there, and he was going to show me all this stuff related to what's upstream of the scablands. And then I had some family matters back in Wisconsin that I had to take care of, so that didn't work. We're set to do the same thing this summer, and now we got this frickin' pandemic, so I don't know if that's going to happen. But he has offered to donate days with me to show me all that stuff. Plus, I have roadside books of BC, etc. I have major interest. I just haven't gotten up there. I'm sorry. I've been spending most of my time down here. But I would love to learn more, especially in the flesh. Did Lake Bonneville drain toward the Cascades or only evaporate? Lake Bonneville flooded once in a major way north towards Pocatello over Red Rock Pass and then down the Snake. YouTube Watcher 806. And since that major Bonneville flood, which was 18,000 years ago, that water's basically evaporated, I guess. I don't know much more than that. Do I have a favorite erratic? It's probably that argillite that we were doing in the rain there in the second half. That's so classic Glacier National Park bedrock down there in the middle of the desert. Pretty amazing. Jackie's also asking about an upper limit to the size of the erratics. I don't know how to answer that. Bruce or Ryan, if you wouldn't mind, how would you answer that? Is there some sort of upper limit, or how would you approximate the biggest erratics that you've seen? Sandy wants the focus clear. I'm sorry, Sandy. I try my best. I don't know how to estimate the weight of the big rocks. Maybe Ryan or Bruce can do that. They're the experts with these erratics. Are there ice age floods in other parts of North America? Bonnie, absolutely. Now, when I took my geology classes in the early 1980s, nobody was talking about ice age floods. I didn't learn about Brett's in 1983 in an advanced glacial geology class. No word of Brett's. I think there's been significant improvement in our understanding of the ice age floods coming down the Mississippi River. There was Glacial Lake Agassiz, which I don't know anything about. I think there was some ice age flooding going down the St. Lawrence Seaway. You're asking about North America. But there's other ice age flood. There's the Altai area of Russia that's a major ice age flood area. So we're not the only place. Evelyn, age 7, are there more erratics near the Wallula Gap where the water drained through? There are plenty of erratics there, Evelyn. You know what? Have you heard of a guy named Stev Ominsky? I'm talking to everybody now, not just Evelyn. Stev Ominsky. He has created these beautiful paintings. He's an artist. And I've been a fan of his work for a long time. And I had a chance to meet him in his home last May. I was driving to Portland, but I set up to meet him. He lives at the base of Mount Hood. And so I got to see his studio and all his wonderful works of art just leaning up against the wall. And here's one of my favorites because it's his portrayal of the Vantage area. I think you saw it quickly in one of the video programs. But based on Ryan Carlson's work and Bjornstad's work and others, this is a wonderful marriage of art and science. And Stev takes particular pride in going back and forth with the geologist to make sure what he's showing is as accurate as possible. Evelyn asks about erratics at Wallula Gap. I just happened to print this one out too. This is Stev's portrayal of one major ice age flood at Wallula Gap, Evelyn. And so there's Lake Lewis in the background. So the Tri-Cities are under the water in the background. Here's the water coming through Wallula Gap, but you can see that if it's a big flood, there's also water cruising over the top of the ridge, the Horse Heaven Hills on both sides of Wallula Gap proper. And notice, Evelyn, he's got a bunch of erratics floating in icebergs there as well. And he's doing that because he knows there's a bunch of icebergs that are going to ground themselves on the walls of the Columbia Gorge and even down in the Willamette Valley. So did I answer your question, Evelyn? Are there more erratics near Wallula Gap? There's kind of erratics any place that the water slows down, Evelyn. And yes, there's plenty of them at Lake Lewis, but there's other places like up the Wenatchee River, for instance, where you can get that water to slow down. I'm having a good time. I'm going to keep going. You're still with us. Most of you are still with us. Did any rocks come out of Alberta via Montana ice? I don't know about Alberta, Mike, but as I've mentioned in other live streams, and it's kind of with the theme of the question about British Columbia, I think it's possible to likely, that we'll eventually start realizing some of our erratics are not from Montana. Some of our erratics are from southern British Columbia. I mean, that might be the way to eventually convince ourselves that some water coming down Moses Coulee, for instance, came straight from BC and was not Missoula water. And it might be matching up the mineralogy of an erratic with the mineralogy of an outcrop in southern BC. And then maybe some surface exposure stuff that just is cherry on the cake. But Alberta seems like a stretch. I don't see how that's possible. Unless you're thinking that you've got, that's not an obvious to me. You might have something in your mind that I don't. You probably do. Doesn't icebergs imply Lake Missoula was frozen over? That was the biggest surprise to me last night. Many of you, Jack, not just you, wanted to visualize glacial Lake Missoula frozen, or an ice cap on the lake. And I've never thought about that, and I'm not quite sure why so many of you like that idea so much. And I don't know how you would find the evidence to prove that glacial Lake Missoula was frozen many times, or you could walk across glacial Lake Missoula for much of each of the years. I don't know. I don't see what you guys are fired up about there. How can the new surface dating technique identify whether an erratic was sitting in its current location versus its prior location? Yeah, Cecilia, I think you're with the other questioner. I guess it was Bill. I think we're assuming that those boulders were not at the surface until the flooding. And I'm not quick enough to think more about why that's an assumption that we all have. But you're right. If it was sitting on the surface up in the glaciated area and now it's sitting on the surface down here, we would have dates that are way too old. I keep coming back to the fact that we've got all these relative age dating relationships without actual numbers, but we know that flood had to come down Moses Coulee, and then this flood had to come down Grand Coulee, and then this had to happen. In other words, just based on the layering of the deposits. And these numbers are fitting nicely into those, they field check basically. And so I don't know if we need to go and toss all those cosmogenic dates out. Clearly most are not, otherwise I wouldn't be sharing it with you. Can erratics be dropped near lateral moraines? Sure, but that's more of an alpine glacier story, Susan. We don't really have lateral moraines, even with ice sheets. These ice sheets are so big that we just have a big terminal moraine and maybe some recessional moraines as the ice goes back. So we haven't talked much about alpine ice, but there was. Did you notice? Come on in here. Come on in. Come on in. Did you notice that this is an alpine glacier coming down the icicle drainage? And there was alpine ice over Leavenworth. So there's some lateral moraines there and a terminal moraine at Leavenworth, you know, where you buy bratwurst and rubber tomahawks. And then there's this ice age flood water coming from the Missoula Floods lapping up against that ice at times. So you've got erratics, in other words, that are glacial erratics and ice rafted erratics from two different sources. A few more, and then I got to go talk to Brogan. Is there loess on the Waterville Plateau near the erratics, or is it just glacial till? There's some loess up there, yeah. They're farming in the loess. Not nearly the thickness of the Palouse Hills, but there's some loess up there. Any stromatolite erratic rocks from Montana, or ripple marks. Not to my knowledge, Greg, that would be sweet, wouldn't it? You've got an erratic that rafted on an iceberg. It traveled, whatever, let's pick a number, 300 miles. And it happens to be a part of the bedrock of Glacier Park or something, or no, that's wrong. Some mountain in Montana that actually had some of the fossilized algae mats or these delicate ripple marks. That would be so perfect to show everybody this is for sure Rocky Mountain bedrock. To my knowledge, I'm sure I would have known about it if somebody had found one of those. Andrea is still at OSU as a postdoc. Thank you. Somebody should hire her. She's very good. Or maybe she's choosing to stay there for other reasons. How about a few more? Bruce is telling us 700 to 800 feet of water above the floor of the Columbia River Gorge at Wallula Gap. Ryan Nickham, one of my students. Is it possible that the subduction of the spreading center created the deep fissures for the flood basalts to come through, or is the timing wrong? The timing's wrong, Ryan, plus it's not the topic tonight, but thank you for watching. Let's do 3 more questions and then we'll finish. How about the Willamette meteorite? Yeah, there's an ice rafted meteorite that was found south of Portland, I guess. I don't even really know where that was. What are the odds? I shouldn't even talk about it because I don't know anything about it. But I know about the Willamette meteorite, and apparently it was a meteorite that got carried by one of these ice rafted erratics. I mean, what are the odds of that? And then the actual meteorite has been sent back to the East Coast in a museum somewhere, but there's a replica, I think, at the University of Oregon's campus. Yeah, I mean, come on. Sometimes you just go, wow, what? This is crazy on top. This is crazy squared, crazy cubed. All right, I think I'm scrolling back now. I think I got most of these, and I apologize if I missed your question. I will feel badly when I see your question. It's a beautiful question afterwards, but it's 7:20. I got to wrap it up. A toast to you. Meant to show you this. This is the Waterville Plateau. All the purple has glacial till and a bunch of milk duds, and then a beautiful terminal moraine across the Waterville Plateau to show that it's the ice sheet itself. All right, this is a premeditated toast. I got some of the erratics in this glass. I'm going to add some milk duds in the glass for flavor. Stir it with, that didn't work. Here's to you and your health, the health of your parents and your grandparents, the health of your children and your grandchildren, the friends, your spouses, your partners, healthcare providers, pretty much everybody on this third rock from the sun. Here's to us. I thank you for joining us tonight. Love to see you again tomorrow night if you feel like you've got the time and the energy. Columbia River Gorge, I think it might be a good show. 6 p.m. tomorrow night. Mima Mounds, Saturday morning. Seattle Tsunami, Sunday morning. Good night from Ellensburg, Washington, USA. I love you.